recording. Gonna share my screen, my PowerPoint presentation. Can you see it now?
Yeah.
I hope you like my design style, the way it looks. Don't judge me too hard. So today we have the fourth class, our fourth meeting, and we're still looking into the topic, which is called Concepts and Introduction into Calculus. And today we're going to focus on problem solving and on your questions. Okay, guys? So outcomes of today's class is going to be as follows. We're going to learn how to solve problems involving average rate of change, and we're also going to look into problems regarding instantaneous rate of change. Any questions?
I have a question.
Yeah, sure.
Is it okay if you email me the presentation or share it with me? Because I'm using my laptop screen and it's pretty small and it's hard to read.
Sure. Let me. Can you tell me your email address?
Here, I'll write it in chat.
Just a second. Chat. You also can find all this material on the Google Drive. I'm gonna upload it after today's class, okay?
Okay, thank you.
So, Yusuf, you got it? Check your mailbox. Alan, do you need the copy on your mail?
No, I'm fine.
Perfect. So, these are going to be outcomes of today's class. And let's make a brief review, guys. So, Alan, would you tell us how you understand average rate of change?
Slope, which is y2 subtract y1 over x2 subtract x1.
Yes, great. And how do you understand the rate of change? What is the rate of change, basically?
It's the rate of change between 2 points. So if you get 2 points on a graph, draw a secant line through them. You can find the average between 0.1 and 0.2 using that the equation.
Exactly. And this average that we're gonna find would be
slope.
Yes, slope, or we can also understand slope as a rate of change of something, right? How one value changes with another value. For example, when we change x, how it's going to affect the value of y. Do you understand that? Because if we take a look into the formula for slope is equal to m, right? So it's going to be delta y over delta x. And we can, if we rearrange this formula, we can see that delta x times m is equals delta y. So basically, over some change of delta x, we are getting certain value of delta y, and m is the coefficient that determines how function would change over run, right? Any questions about this?
No.
Perfect. Yusuf, can
Yeah.
you be so kind and tell us what about the instantaneous rate of change?
It's the change in the like it's a change in a concentration of rate that occurs like at an instant amount of time. Yeah.
That's good answer. That's really good answer because you said instant amount of time.
Yeah.
So by that, I can suppose that you mean that we're taking a look into our graph, yeah?
Yeah.
When we have a variable and we assume that this variable instantaneous has instantaneous value in this point, And we are evaluating the function in approximately this point, right? And can you remind me for this is the formula for the average rate of change. y1, y2 subtract y1, x2 subtract x1. And can you tell me how we would change it? This is the formula for average rate of change, right?
Yeah.
How would we adjust it to get an instantaneous rate of change?
Make it like I can't remember it. It was
Take your time, don't worry. So can I give you a hint?
yeah,
So remember that when we are looking for an instantaneous rate of change, x1 and x2 are extremely close to one another, right?
yeah.
These 2 points on the graph, they're somewhere close. And we need to define how close they would be. And this some difference where x2 equals x1 plus something. What is this something? If we have a graph and x1 is here,
Yeah.
x2 is here, and this term that we're adding, it would be a difference between these 2
Oh, it
points.
was H.
Yes, exactly. We
Yeah.
can call it H. And when we're looking into instantaneous rate of change, there is a specific thing we're doing with this H. We say this H is equal not to 1, it's not equal to 2, where we want this H to be as close as possible to what value?
0.
Which value do we want to approximate H with? Well, we want to say that H is equivalent or close to or traveling to.
0.00001.
We can
Or
unite this term in a simple limit function. And if we would group up in limit, can Yusuf answer this question? If we use limit function to represent the instantaneous rate of change, what value are we limiting?
The X.
Yes, we're saying that x is limited to some point on the
Yeah.
graph, right? But to limit this value of x in this point, we are affecting h somehow.
Yeah.
So what we do with h? If we want x2 be extremely close to x1.
Yeah. So we have to make H like the least number possible.
Pardon?
H has to be like a small number.
Yes, so or we can say that it can travel to 0.
0, yeah.
Exactly, great. So now we remembered both of crucial formulas. Please remember them because they're needed to solve the problems. And I suggest you dedicate the next 10 to 15 minutes to watching a few videos on YouTube. How you like it?
Okay, sure.
Yeah, let's take a look into these videos. Take notes, work as it the best for you. You can write down, you can memorize, wherever you choose, okay? It's just gonna give us an overview of 2 examples, a few examples. I'm gonna share the browser now. Can you see my Google Chrome?
Mhm.
Can you hear the video?
No.
Do you have sound?
Make it louder. I could hear it, just not as loud.
Rate of change
There
of
we
a
go.
function.
Oh, I can now, yeah.
It works now, right?
Yeah.
So this we already covered theory together with you guys over past classes, and now take a look into example how people are actually solving these tasks. Okay, let's do it.
Then we're going to focus on calculating the average rate of change of a function over an interval. So here's the formula. The average rate of change is f of b minus f of a over b minus a on the interval a to b. So a and b are x values. f of a and f of b, you could think of them as y values. So first, let's calculate f of a and f of b. In this example, a is 1, b is 3. So let's calculate f of 1. We just need to plug it into this equation. So it's going to be
When you muted your mic, the volume stopped.
Yeah.
1 is 0.
Better?
Now what
Mhm.
about f of 3? That's going to be 3 squared plus 4 times 3 minus 5. 3 squared, 3 times 3 is 9. 4 times 3 is 12. And 12 minus 5 is 7, so we have 9 plus 7, which is equal to 16. So that's f of 3. So now let's use this expression. So that's going to be f of 3 minus f of 1 divided by 3 minus 1. F of 3 is 16. F of 1 is 0. And 3 minus 1 is 2. 16 divided by 2 is 8. So the average rate of change of the function over the interval 1, 3 is equal to 8. And that really represents the slope of the secant line.
Okay, guys, let's make a stop here. I would like you to concentrate on the algorithm, right? How we are approaching our problem. So here, what I suggest to every one of the students is to go back to the question, what it's asking you about, and based on that, we're gonna plan our solution, right? So in this case, question says determine the average rate of change. And first thing what I would do, I would write down the formula for the average rate of change right away, right? And now we just need to take into account what values do we already know and what values do we need to find, right? So in this particular example, we know position of X at the beginning and at the end of the run, right? We have A equal to 1, B equal to 3. We already know these two values. So just leave it aside and let's focus on what we don't know. For this example, we needed to find the value of a function at point B and the value of a function at point A. Since once we found those values, we just simply substitute them in the known formula, evaluate it, and we are getting the right answer. And I want you to keep in mind that this formula is equal to m, and m is the slope of a tangent of a secant in this particular case, because we are not looking into tangent line at a point, but instead we are looking into secant, right, between 2 points on the curve. Any questions about this?
No.
Perfect. Let's move on. Just give me a second.
Secant line. So let's plot a generic graph, one that's not related to the last example. Let's say we have a graph that looks like this. And we want to find the average rate of change between points A and B. So that's on the interval A, B. The average rate of change, it gives us the slope of the secant line. And a secant line touches 2 points on a graph. A tangent line only touches 1 point on a graph. So that would be a tangent line. So keep that in mind. The average rate of change represents the slope of the secant line. Number 2, calculate the average rate of change of f of x equals x cubed.
Any questions about the graph, the plotting of the graph?
No.
Can you tell me why he made graph look like like a vertex? Let's go back to the question so we can see the equation. Can you see it on top of the screen?
Because it's a quadratic.
Yeah, because we can see that the power of x, the greatest power of x is 2.
Yeah.
Great. Okay, let's move on.
Number 2, calculate the average rate of change of f of x equals x cubed minus 4 from x equals 2 to x equals 5. So it's going to be f of b. Well, first we need to know what a and b are. A is 2, b is 5. So it's f of b minus f of a over b minus a. That's the average rate of change. So this is going to be f of 5 minus f of 2 divided by 5 minus 2. So to calculate f of 5, we just got to plug it in to that formula. So that's going to be 5 to the third minus 4. And to calculate f of 2, it's going to be 2 to the third minus 4. And 5 minus 2 is 3. Now, what is 5 to the third power? 5 to the third power, that's 5 times 5 times 5. 5 times 5 is 25. And 25 times 5 is 125. Now, 2 to the third, that's 2 times 2 times 2, which is 8. 125 minus 4 is 121. 8 minus 4 is 4. And 121 minus 4 is 117. So it's 117 divided by 3. And 117 divided by 3 is 39. So 39 is the average rate of change from 2 to 5, or in the interval 2, 5. So now you know how to calculate the average rate of change of a function.
Any questions about this example?
No.
No.
So, Yusuf, can you tell me how different is this solution from the previous one? There's only one thing that is different.
But from which solution? Which one?
From the first example, from this one. How these two examples are different?
Can you go back to the other one?
Yeah, the answer is pretty obvious. I'm not asking something specific here. We can see that the algorithm is the same. Formula that we are using for solution is the same. The only difference is at certain stage when we are evaluating unknown values of our function, right? F of b and f of a.
That's the only difference?
Yeah, basically, I wanted to stress that algorithm is the same, even though initial formula has different form. In this case, we can see that the graphing would be even more different because x is to the third power. So, but still, algorithm to finding the average rate of change is going to remain the same.
Oh, okay.
So, no matter how does your initial formula looks like, you always stick to this formula for the average rate of change. And fun fact, in instantaneous rate of change, you're gonna stick to the same formula, but you instead of putting in 2 points for x, right? We're using same point for x, where x2 is equal x1 plus h, right?
Yeah.
So for a and b, for b we're gonna use x2. For a we're gonna use x1 with no additional term. Is it clear?
Yeah.
Perfect. So let's take a look into another video. It's also gonna be a quick one.
What? Still searching?
Now, the next thing we're going to talk about is the difference between the average rate of change and the instantaneous rate of change. So let's say if you're given a function f of x is equal to x cubed, and the question asks, what is the instantaneous rate of change at x equal 1? The instantaneous rate of change is simply f prime of 1. You just got to find the first derivative.
You see here, he's using another method to find the instantaneous rate of change. And that's how we're going to get to the derivatives from limits, okay? Here you can see that he's using the derivatives formula. We're going to take a look into it a bit later. But in fact, this is the value that he get for the instantaneous rate of change. And let's use a formula that we know to evaluate the instantaneous rate of change. And the formula that we know is f of x1 plus h, subtract f from x1, divided by x1 plus h, subtract x1. So who would like to try this example using known to us formula?
Well, what points do we have for the x?
For x, we have point equal 1.
Okay.
Wait, what are the points?
We have only 1 point, x equal 1.
Oh, okay.
So would you like to write it down first and then say your answer, or you can say and I'm going to write it on the board? Take your time.
Wait, just to make sure the formula is x squared, or what's the formula?
To the third power, x to the third power.
X cubed, okay. So it'll be 0 over. Is it just 0 over 0?
Let's take a look into it. And so first of all, let's take a value of the function at a point. At the point 1 is going to be 1 plus h to the third power, because this is our initial formula, right? And we're sticking in the value of x, subtract 1 to the third power, and 1 plus h, subtract 1, right?
Mhm.
Now, what we're gonna do here is,
Expand it.
what would be the formula if we extend this brackets?
1 plus h times 1 plus h times 1 plus h, subtract 1.
Or you can extend it in another way. Use the third power of a sum. Do you know this formula?
Yeah, it's using Pascal triangle. It would be 1, 2, what is it? No, it's 1, 3, and then 1, 3, 3.
Um,
It's 1, 3, 3, 1. So would it be 1 plus 3h? No, I forgot how they taught me.
well, let's check the formula. So here we have a formula table, and we can see it's going to be a to third power. So
Oh yeah, 1, 3, 3, 1. It's a to the third.
8 to the third power.
1 to the third
Okay,
power.
okay, can you write it down, memorize it? 8 a to the third power you got the formula? A to the third power plus
3 to the a squared times b. I just didn't get it all the way down.
write it down into your copybooks if you see it. Can you see it on the screen?
Yeah.
Write it down, please. You're gonna need it in future because you may have tasks with formulas like this.
I got it.
So now tell me the formula, please.
It's gonna be
Wait, can you go back?
Back to the formula.
Yeah. Okay, I got it.
so it'll be 1 cubed.
Can you just say the formula?
Oh, a cubed plus 3a
A
squared.
cubed plus 3 3 a
Yeah.
squared.
Yeah,
Okay.
and then b.
Plus, okay.
It's b at the end. Just multiply by b. It's 3
Oh,
squared,
I got it. I got it. Okay.
and then plus 3ab squared.
3a h squared, right?
Yeah, and then plus b squared.
Plus a squared.
That's everything.
That's it, right?
Yeah.
Let me double check it.
Oh, I got one of the signs wrong, actually. No, wait, did I?
Yeah.
No, we're
Here.
adding. Yeah, I got it right.
3a squared, 3b squared, b cube. B third power. Right square.
Last one's cubed.
Yeah, last one is cubed. And all together divided by h. So now interesting. Just give me a second here, guys. Gonna use the
Subtracted by-
limit approach.
Subtracted by 1 cubed.
Pardon?
Have to subtract by 1 cubed.
Sorry.
Subtracted by 1 cubed. The equation. Because we expanded it, but we didn't add the subtract 1 cubed at the end.
Oh. Like this?
Yeah.
I'm not sure. I believe there is no additional term in there. Sorry.
Well, no, because in the equation before it said
Uh-huh.
h cubed subtract 1.
Subtract fx1. Exactly. So,
And then can we just cancel those out?
pardon?
Can we cancel those out?
So yeah, we're gonna cancel these out, and now we need to simplify this h, right? And what we're gonna do, we're just gonna throw one h out of the brackets. We got common multiplier, right? And we're gonna leave 3 times 1 a square, or just 3 times 1 plus 3 times 1 times h, because we put h out of the brackets, right? And h a square. Finally, we got it. Look, and here's when the magic happens. You see, because we said that h is traveling to 0, but it's not equal to 0, we can substitute those multipliers here because we cannot divide 0 by 0, but we can divide small one by small one, right? So we're dividing that, and now we're sticking the values for h into this formula. What we are left behind? 3 times 1 plus 3 times 1 times h plus h a square, right?
Mhm.
So this value, we can say that it is equal to 0 when h travels to 0, right?
Mhm.
Makes sense.
Mhm.
This one is equal to 0, so this whole product is going to equal to 0. And all we have left is 3 times 1. And 3 times 1 is equal to 3.
Okay.
And now you can see that we got the same answer as our internet friend did, but instead of using derivatives, we used limits. And at this stage, I expect you to understand that limits are not just some kind of silly function. It's just a way for people to explain derivatives and come to the understanding of the derivatives.
Mhm.
Any question about solution in this case, guys?
No.
Yusuf, what about you?
I didn't really understand.
Sure, ask.
Can you explain like what the second step was? I got lost at the second step.
Yes, sorry for that. Can I explain from the very beginning the logic of this assignment?
Yeah, please.
So again, to begin with, we missed something important here. It's a limit function. Limit h traveling to 0. First thing first, we look into question. Question says find the instantaneous rate of change of function at point x equals 1. So we know the formula for instantaneous rate of change. This is the formula. I just changed x2 to x1 plus h. That's clear, right?
Yeah.
So once we got the formula done, second step is to evaluate the function at specific point, right? Find the f of x1 plus h. So we take x1 plus h and stick it into this formula instead of x. Make sense?
Yeah.
We would write 1 plus h to the third power, subtract function from x1, and x1 is equal to 1. Make sense?
Yeah.
Next step, we write it the denominator, we simplify it. Here we extend the brackets, not by simply multiplying it 3 times. Not just like this. Instead of that, we're using the well-known formula for a plus b to the third.
Oh, okay.
We're using this formula, we expand the brackets. After expanding the brackets, we are getting these. This is equivalent to 1 plus h to the third power.
Okay.
A is 1 in this formula, B is h in this formula. You see?
Yeah.
Once you did it, next step, you simplify it by substituting common terms. In this case, it's subtract 1 to the third power and plus 1 to the third power. We can simplify it, throw it away. Next step, what you need to do, you need to simplify h in the denominator because we can't leave an equation like that. We cannot divide it by 0, right?
Yeah.
So we want to simplify it. To get rid of this h in denominator, we extracted common multiplier from the brackets and put it in front of the brackets right here. Can you see it?
Yeah.
So once we did it, we can easily simplify it because h is not equal to 0. It's close to 0, so we can simplify it. Otherwise, you would get inaccuracy, error on the calculator.
Yeah.
But in this case, we can, so we simplify it. And the last step is to evaluate the value of a function at this point.
Oh, okay. I got it now.
Maybe any other questions?
No.
So I hope you understood this idea of instantaneous rate of change as a limit function, right? Because you can see a comparison of two styles. The person that we are looking presentation at, he said he used derivatives. This is the sign for derivative of a function, and he got the same answer. So, in difference between our method and his method is that we are using a bit different shape of the same thing. In fact, in math, limits and derivatives, they're strongly interconnected, and we're going to take a look into it in our next classes. Did you write down the solution for this case?
Yeah.
Perfect. I'm going to clear the board now. Alan, you okay?
Yep.
So let's continue watching this video. Maybe he gives us another good example that we can practice with.
Fx, that's a change. At a point
So
is the same as the instantaneous rate of change. So for this
case, he added an additional property. He said, let the tangent line at a point have a rate of change equal to m. Right? Slope equals m equals 1. Make sense?
Yeah.
So now he's going to solve this task other way around. Let's say we know that the instantaneous rate of change at the point should be equal to m equals 1, and we would like to find such a point. Can you explain me how would you do this task in this way? If we know m, but we don't know at which point. We know the function, but we don't know at which point. I will give you a hint. Take a look into what we already know and try to understand what we want to find.
So we know the slope
Yes.
and we know x equals 1.
No, we already evaluated that at point x equals 1, the slope would be 3.
Okay.
So it's not the same point. It's some other point of a slope.
Okay.
But you know m, that's good.
Is M3 or M1?
M1.
Okay. And we're trying to find, what are we trying to find?
We're trying to find at what point it's equal to 1.
Okay. Well, it could be multiple options. Can it not?
For this function,
Oh, for this function. Okay.
for this specific function,
Which one? The top one, the x cubed or the 3x squared?
x cubed.
Okay.
3x squared, don't look at it. It's the one he got using derivatives.
Okay. Then you could use
So let me give you a hint, okay? We're going to use the same formula for instantaneous rate of change.
okay.
We're
So
just gonna need to find
f y2 and f of y1.
So you can easily change these values. Right now you have 4 unknown terms, right? We don't know all of these terms. Let's say, what is y2 equal to?
1.
No, we don't know at which point. Just in letter expression.
X plus h.
X plus h and third
Cube.
power.
Yeah.
Y1 would be equals x to
Cubed.
the third power. Yes. And x1 is equal x1.
Yeah.
I got you there. And x2?
X plus h.
X plus h, perfect. And now let's take these values into the formula. X plus h to the
Okay.
third power.
And if we solve for that and then plug in 1 for x and then 0
No,
for
no, we're gonna plug in 1 for m. Keep in mind.
okay. I'll see then what happens.
So our formula is gonna look like this. X plus h subtract x. Simplifying it. Expanding the top part. And we already know that we're gonna have something like x to the third power plus x times h plus h squared. Is it right? Let's do it in
I
another.
don't-
Okay, remind me the formula that we just used for the third power of a sum.
x cubed
X cubed
plus 3
plus 3
x cubed
x
b squared
x x squared.
b
In our case, b is
Or-
h. Okay,
sorry plus
3.
3x h squared.
Okay, and plus h cubed.
Yeah.
All divided by h. Now, Yusuf, can you hear me?
Yeah.
As well as in the previous exercise, what would be your next step in here?
Next step is to find h, right?
Almost something with h, not fine, but
Uh, simplify.
yes, exactly. First step, we would get rid of this x to the third power. Next step, we would extract h from here, and we would get formula like this. Oh no, like this, right? And now we simplify it, and all we got left is this bracket, right?
Yeah.
We got this bracket. We move it here. Ooh. Okay, let's leave this weird 2 here. So now we know that this thing to the right-hand side of the equation should be equal to m, right?
Yeah.
When h is limited or traveling to 0. So how would you write down this new equation we found out? Oh, basically, it's the same equation, but we simplified it, we changed it. We already have it here. Left-hand side would be equal m, and right-hand side would be equal to this bracket.
Yeah.
So let's stick in 1 here and apply limit h equals 0 or travels to 0. This is going to turn into 0, right? This is going to turn into 0. And all we have left is 3.
Oh, okay. So then you'd have 3x squared equals 1. But if we isolate for x, you'd have to divide it by 3 and then square it.
Square root.
Square root, sorry.
And this would be the answer. This would be the point at which m is equal 1. This point is x. Let's call this point a, okay? A value of x in this point is 1 divided by 3. And you can also find the value of a function at this specific point, right? It would be 1 times 3 times 1 over 3 square. Because we know the formula, x to the third power. And now we found the point. We were given with the slope of the instantaneous rate of change, and we found point using that values. Please ask me questions, guys.
I understand this.
Yeah, me too. Just
Good.
like manga, yeah.
Now it makes everything makes sense, right?
Mhm.
Perfect. So let's take a 15 minutes break and get back to the problem solving. Okay.
Okay.
Okay, guys. See you soon.
See you.
Hello, guys. I'm back. Are you?
Hi, yeah, I'm here. Yep.
Hello, Yusuf, Alan. Great. So we have one new visitor into our lecture. Would you like to say something, co-host?
Hello.
You know, maybe they have their reasons. So okay, let's not waste our time and get back to the course. So here on your screen, you can see a cheat sheet. Here's basically all the formulas that we looked into since the beginning of the course, right?
Yeah.
And it's not an accident why I arranged them exactly in this order. Because first formula, you already know it prior to coming to this class. It's slope of a line, right?
Mhm.
The second formula, it's a slope of a tangent as a limit. And here I want you to focus on that. It's a limit function. That's what makes this real, this whole thing possible. I would read this equation as m, or slope or rate of change, is equal to the limit while delta x traveling to 0 for delta y over delta x. And next line is limit when h is traveling to 0, function at the point a plus h, subtract function at point a divided by h. Next one, they're in this particular sequence because the second one is based on the knowledge about the slope, right? We just adjusted the values that we are using to determine the slope, right? We gave it specific feature because for average rate of change, h could be any value. We can take 2 any points on the graph. But for limit, h is going to be restricted to values close to 0. Okay? And that's the difference between average and instantaneous rate of change. Here you can see that instantaneous rate of change is basically a slope of a tangent as a limit. Same formula. Here we're taking into account that we're looking into instantaneous rate of change at point where x is equal to a. So let's say if there was a slope looking like this, and we would take point here, and we would like to know the tangent at a point, this would be a on x-axis, right? And value for this function at this point would be f of a. Make sense?
Yeah.
Perfect. And instantaneous velocity. Here you can see connection between this mathematical analysis of a graph with real practical physical implementation. Because what the only Yusuf, can you tell me what's the difference between these two formulas?
Instantaneous rate of change in velocity.
We came up to the conclusion that instantaneous rate of change is equivalent for instantaneous velocity at some
Yeah.
cases. Velocity, in what cases we have velocity? When we have
Moving
distance,
object.
when we have moving object, exactly. And when the object is moving, it has a path that it covers, and it has a time over which this path has been covered. Make sense?
Yeah.
Time 1 and time 2. If you take a look into this, this is nothing more than x and y axis, right? But when we're looking into rate of change in terms of y and x, we're looking into how y changes with x. in this case, when we're talking about distance and time, we're talking how distance that we cover changes with time. Do you see connection here?
Yeah.
So when we say that the average rate of change between these 2 points, it would be average speed of an object traveling between these 2 points, right? But
Yeah.
if we take an instantaneous rate of change, we would say this is instantaneous velocity of an object at the specific point. For example, if you know that the car, we can describe the movement of a car by, let's say, just a straight line. Sorry. If we can describe the movement of a car as a straight line, we know that slope of this line at this specific point would be equal to velocity. Makes sense?
Yeah.
Beautiful. So please write down this formulas in a simplified way, just simply average rate of change dash this formula, this formula, this formula, and this formula. Write it down in your copybook, and you can use it as a cheat sheet for your future assignments. So you don't need to go to the internet or search for this formula wherever again. It would be in your copybook till the rest of your life. While you're writing it down, please feel free to ask any questions. Let me know as soon as you're done.
I'm done.
Perfect. Waiting for Yusuf.
I got it.
Perfect. Let's move on, and we're going to dedicate the remaining of our class to. Can you see the screen, right? You're
Yeah.
going to dedicate it to practicing problem solving, and we're going to begin with problems involving tangent lines. And we don't have much time left. I would like to ask you guys, looking at this task, do you feel like it's complicated for you at this point, or you understand how to solve it?
Well, it's just yeah, I could solve it easily.
Yeah.
Yusuf, what about you?
Yeah, I could solve it.
Let's solve just one together, one
Hmm.
of them. So let's choose which one you like.
I would say B. It looks probably the most challenging out of them all.
Okay. So
I did
let's
the first one.
you want to solve first one.
I did the first one, yeah. But we can do A and B.
Let's do both. I would start with A. So determine the slope of the tangent to each curve at the given point. So let's write down what point do we have. Let's denote the point as P. Remember, because in the book, we had 2 points that forming a second line, it's P and Q, right?
Hmm.
Let's stick to this notation. So we have point P, which is 2 minus 2. It means that x at this point equals 2 and y equals minus 2. Let's check it. Well, why not? Let's take this value into this formula. X equals 2. It's going to be x squared 4. Subtract 3 times 2. Subtract my 6. Minus 2. Perfect. It's all right at this point. Now we need to determine the slope of a tangent. So first thing you do when you hear these words, you say what we do.
The next thing is to sub them in.
No, once we hear the words, determine the slope of the tangent to the curve at specific point. Once we heard those words, next step for us, this is first step, find the point, and second step, we're gonna write down the formula for the tangent at a point.
Yeah.
And this formula is specific because we're using limits here. We're gonna say limit delta x traveling to 0 equals
Delta y over delta x.
yeah,
Or-
let's skip that.
Okay.
We're gonna write, let's, instead of writing y and x, let's write function from x and x, okay? Like in the second example, you see here, instead of y, they're using f of x.
Then
So we're gonna
x-
write the yeah, sure, go ahead.
x to h, x plus h.
Yes, we're gonna find a fx plus h, subtract,
f of a or f of x, sorry,
yes, f of x
over h.
Yeah.
over h. But here you can easily say it's over h because you already remember that x are simplified there.
Mhm.
So a next step would be to find unknown values. Basically, what we don't know here is fx plus h, right?
Mhm.
F of x plus h. It's the value of a function at second point we're taking.
Mhm.
I would stick x plus h into this formula. Let's go ahead and do it.
So substitute 2 for x.
So we are substituting x in the given formula for x plus h.
Mhm.
Oh, okay.
So let's stick it in. We see that x squared, you said what it would be in our formula.
It would be Wait, I'm confused now.
Keep in mind that you are sticking in x plus h instead of x in initial formula. Initial formula is as given. Imagine if imagine there is a blank space for where x is written. Blank
Yeah.
space here, 3 times blank space. And we, instead of this blank space, we're just gonna stick in x plus h. X plus h. Do you get it?
Not really, no.
Let's refer to the formula. Instantaneous rate of change. Can you read it for me? Just without the limit, just the division part. Can you read it?
Yeah, 1 second. It was fx minus fx.
Yes. And what is this fx plus h means?
It's plus the distance between 2 points h.
Pardon?
H is the difference between 2 points, right?
Yes.
Yeah.
So when we're looking into function of x plus h, we like to know what y is equal when x is equal x plus h. Does it make sense?
Yeah.
Because what you're writing in the brackets here, it's the value of the variable at a point, right? F O x plus h is the value of function when the variable takes value of x plus h. And f of x is the value of the variable when x is equal to x, basically. Does it make sense?
Okay, yeah.
And what is f of x equal in this case?
The 2.
No, almost. 2 is the value of x in this point.
Oh yeah, yeah.
And value of f of x would be
Sir, I'm going to the bathroom really quick.
pardon?
I'm going to the bathroom really quick. I'll be back.
Yeah, sure. Take your time. So Yusuf, let me give you a hint somehow. So what we're looking at, you already know this formula for the slope, right? It's delta y over delta x.
Yeah.
We can, there is 2 different notation for y in math. It's y and f of x.
Okay.
Makes sense, right?
Yeah, makes sense.
So here, instead of writing y2 subtract y1, we're writing the value of a function at point 2 subtract value of a function at point 1.
Okay.
So for point 2, we're taking x equals x2 equals x plus h. Small step. Our incredibly small step as we imagine it, right? And
Okay,
for an x1 is just the value of x. For this case, x in the formula is the point where we're looking for a tangent at a point. So we're looking for tangent at a point 2, comma minus 2. It means that value of x at this point is equal to, and value of a function when x is equal to would be minus 2. You can check it by sticking in x equal to into the given formula. Clear so far?
Yeah.
So once we know it, now we're writing down the formula for the instantaneous rate of change. It's also exactly the same formula as in your book, right?
Yeah.
And in the denominator, we have y2 subtract y1, or value of a function at point x plus h, subtract value of a function at point x. So what I would write here, instead of these brackets, I would take this initial formula, substitute x for x plus h, and just simply write it down as it is. So can you tell me how would the formula look like if we substitute x for x plus h in this case?
So
Imagine
just
that,
fx, right?
pardon?
It would be just fx, right?
No, this would be fx plus h. Fx, it's already here.
Yeah.
It's already here, basically, right? You already know the value of a function at this point. F of x would be equal -2.
-2, yeah.
But f of x plus h would have a different value. So you're just substituting x for x plus h. What if instead of x plus h, I would just say x2 here? How would you do it that way?
Oh, okay. So it would just be like x just it will be x because we don't know what's x plus h is, right?
Yes, because we eventually we're going to first of all, we need to simplify the formula before we can give an answer. So let's just write it down in the most simple way we can without evaluating it yet. Okay? So imagine if there was x2 instead of x plus h in these brackets. How would you rewrite this formula for A, equation A? You would substitute the value of x, the value of x2. So Yusuf, did you get it?
Kind of, yeah, but not really.
So what if I would say, instead of x2, I would say 4 here? How would you evaluate the value of a function here? At x equals 4.
Yeah, just like solve it.
Yeah, you just stick in the value for x here, right?
Yeah.
And when we have x plus h here, it's pretty much the same. You're doing the same algorithm. You're solving it for x plus h. So just tell me, what would you write if you know that x is equal x plus h?
Oh, so just write an x, just replace it with x.
Replace what?
Replace x plus h with x.
Oh, the other way around. Yeah.
Oh, so replace x with x plus h?
Yes, exactly.
Oh, okay.
So you're replacing it, and you're writing x plus h a square, right? Because x is a square as well here, right?
Yeah.
Subtract 3 times x plus h.
Yeah.
And subtract, let me move it to the next line. And now you subtract f of x. Because this part is this part. You see it?
Yeah,
Kind of makes sense. We just replaced f of x plus h with the actual value of a function at this point. This would this is how we would evaluate the function at point x plus h. And next step in the instantaneous rate of change formula, Yusuf?
yeah.
Go ahead. Subtract what?
Then you would subtract f of x,
Yeah, and what is f of x in this case?
2.
Almost.
Minus 2, sorry.
Yeah, exactly. And here we write in the denominator
H.
yes. Now we can stick value of x equals 2 here, right?
Yeah,
Because that's the point we're looking into. Do you understand why we choose x equal 2?
yeah,
Because it's the point that we're looking in.
yeah.
And x plus h, if x1 equals 2, then x2 would be equals 2 plus h. So let's go ahead. It's going to be 2 plus h a square. And do you know the formula or how to simplify it?
Oh yeah,
Expand it.
it's gonna be x squared plus x plus h, no, x times h.
2 square plus 2 times h plus
2 times xh.
no plus h square.
Yeah, but for the middle term, it's xh.
2 times xh.
Oh wait. Okay, you're substituting it in right away.
So here we should say 4x
Yeah.
a square plus 2ab plus b square.
You just put x equals 2 right away, so I didn't. That's
Mm.
what. And then
So-
that's gonna be 3, subtract 3x
Or
plus
6.
oh yeah, sorry.
So
Subtract
we're opening the bracket. We're multiplying 3 times x and 3 times h.
and negative 3h. Or subtract 3h.
Yes.
Uh,
And we add 2 eventually. And we divide it by h.
mhm.
Let's simplify it.
4 plus 4h.
Let's group it up right away by it's gonna be 4.
H plus h.
I would say, look, let's look at the terms without h first.
Okay.
That's how I solve it for convenience. So 2 a square, then minus 6 plus 2.
So 0.
Yeah, so right away we know there is no terms without multiplier h, right? Then 4h subtract 3h, so it's 1h.
It's gonna be h plus h squared.
H squared
H.
divided by h.
And then your answer is gonna be h.
No.
Well, if you divide
Yusuf, remember in the last task, we tried to simplify it at this stage. Do you remember, Yusuf?
Yeah, we simplified, yeah.
And how would we simplify it in this case? Common multiplier.
Yeah.
And what would be the answer?
1 second. 1 plus h.
Yes, exactly.
Yeah.
Eventually we're gonna get 1 plus h
okay.
divided by h. We simplify h, and we know that 1 plus h is our value of a tangent at a point. And we are applying at the final step. That's the very final step when you're doing it. Once you simplified it completely, then you stick in h equals 0.
Okay. Yeah, I got that. So then your
So the
is-
answer would be 1.
Yep.
Any question about this example?
No.
Yusuf,
No.
you got it, right?
Yeah.
Perfect, guys. Do you need time to copy what's on the table?
No,
What's on
yeah.
the board?
I could finish this one on my own.
Yusuf, I'm good to go?
Yeah, I'm good.
Sure. You wanted to solve B, right?
Well, I could do it.
Yusuf, would you like to solve B? Or
No,
move
it's
on?
okay. We
Okay.
can move.
You would do exactly the same steps. You
Yeah.
write down the formula for instantaneous rate of change, and you just stick in the values that you're giving this. Perfect. Let's move on to the next example. Determine the equation of the tangent to this function at 0.31. Okay. Okay, guys, I'm gonna give you 2 minutes. Tell me, how would you solve this task? And then I'm gonna tell you my solution.
So first you'd use your equation of the tangent. Oh, equation of the tangent. Is that the same thing as the slope?
Mhm.
Is it like the same formula, the f equals x plus h, subtract f x over h?
Mhm. Mhm. You're in the right direction.
Yeah, I could do this then.
But don't rush too fast. Let's write down the equation of a tangent at a point. Let's start with it. We would say limit delta x traveling to 0, limit m, because this is our slope, right?
Yeah.
Let's say limit now h traveling to 0, m f of x plus h, subtract f of x divided by x plus h, subtract x, simplifying, getting this. This is the formula for the tangent, right?
Yeah.
Remember in the videos, we were solving example where we know the m, the slope, and we wanted to find at what point would be certain value for m. This is pretty much the same task as the previous one, but we're gonna do it a little other way around. Determine the equation of the tangent. So let's let's recover in mind. How does the equation of a line looks like?
Quadratic.
No, line.
Oh, line, sorry, linear.
Yeah, it would be linear. It would be m times x plus b, right?
Yeah.
So if you were asked to determine the equation of a line, you would need to find m and b, right? Make sense?
Yeah.
So here, pretty much, we're gonna do the same stuff, but we're gonna make it a bit easier, because basically what this is it's already equation of a tangent line, right? But
Yeah.
here we have no variable, we have no specific variable, we have no function, so we need to rearrange it so it looks like this. So what I would do, I would keep evaluating this formula. Let's work with what we know, right? We know this, we know equation for a tangent at a point, right? We know it. We were giving with it in the copybook. Then let's just use it. So, Yusuf, what would be f of x plus h in this case?
It would be 2. I mean, 3.
No, not at all. F of x when x equals 3 would equal 1. And what about f of x plus h? I don't need an answer. I just want to know how would you write down this?
Is this for me or Yusuf?
Sorry.
Yeah, Yusuf, how would you write down f of x plus h? How would you write down this part in the line to solve it? Using x equals x plus h, and this is the given formula.
Oh, so just like sub it in.
Yes. So tell me, what should I write?
So fx. Oh, no, sorry, x squared.
You sure?
Oh, wait.
X plus h we're using.
Oh yeah, x plus h.
Okay.
Minus fx.
Not
Wait,
yet.
no.
We need to
Yeah.
complete the full formula first. Look here. You need to write down this, but instead of using x, use x plus h.
Oh, okay. So minus 3x.
Minus 3 xh.
Oh yeah, right here, right? Because yeah, plus 1,
Mm-hmm.
and then minus fx.
Minus fx. And
Yeah.
we already know the value of fx.
Yeah.
And what is it?
3.
No,
Oh, so
3
sorry,
is...
1.
Yes, exactly. Perfect. Don't be sorry. We're okay. So next step, let's sticking value of x3 in here. Expand it using the same formula. 6h as 6h plus h squared, subtract 3x, subtract 3h. And we are simplifying 1, right? H here. Now, instead of 3x, we are writing 9, right? So what would be the next step? Group up common terms.
Yeah, so the 9s would cancel out. And
We would have 3h,
so I
these two terms.
did it wrong on my paper. I missed a step.
No worries. That's why we're doing it together.
And then you would have 6h plus h squared, subtract 3h.
Yes.
And then you would have over h, sorry. And then you could simplify that down. So if you factor out an h, you'd get h bracket 6 plus h subtract 3 over h. And then you could subtract those h's, you would get 6 subtract 3 plus h, or you could just write 3 plus h. And then set h to 0 and get x equals 3.
Not x, but m equals
M.
3. So we know that slope of a tangent equals 3 at this specific point, right?
Mhm.
We finally found it. Good?
Yep.
So, let's now... So now we know that m is equals to 3. Now let's write down the formula for a just give me a second. So we know M, and we need to find the equation of a line, right? How we can find the equation? Any suggestions?
The equation of the
Tangent.
yeah, you already have, well, you have everything. You would do y equals, and you have m, so it'd be 3x plus 1, wouldn't it? Because you would take the c value of the, oh wait, no. Yeah, would it?
So what I would do in this case, remember the equation for tangent for a line
We could
is
solve for it, actually.
mx
Yeah.
plus b. So we don't know b yet.
We know
We know-
y. So if
we know-
substitute the, if we like rearrange it, so we get y equals y over mx equals b, and y subtract mx equals b. Sorry.
Mm-hmm.
And then we sub in 1, subtract 3 times 3. That'll equal to b.
Perfect.
And then that would equal 9. So b equals 9. So your equation would be y equals 3x plus 9.
So you good, Alan. Good, really good. You see, you successfully use this method when you're looking into what you already know and you look into what you're being asked to find, right? So, Yusuf, did you understood?
Yeah, kind of.
So basically, what you're asking for, find the equation of a line. You know how does the equation of a line looks like, right?
Yeah.
This is this formula where some m is the slope plus b offset. And what is this offset? Can you remind me? How it affects our graph?
Is for Yusuf or for me?
Alan, do you know the answer?
I'm not sure.
What was the question again?
How b offsets our line on the graph?
Like how it, like what it means?
Yeah, what it affects.
Well, the b is the y coordinate of the tangent line. So it's where your tangent line would be placed. It wouldn't really affect anything.
In fact, b would affect vertical displacement of a line. Remember? Because if you take a look here, if x equals 0, y without b would equal 0 too. But if we have certain b, y would equal b. So b is basically y-intersect.
Yeah.
Make
Oh,
sense?
okay. Yeah.
And also b would be the displacement of our line vertically for some value. We could move our line higher, lower, but in general case, line should go through 0.00 if we don't have b. Make sense? Because if x equals 0, then y is also equals 0. If we add b into our function, then the value begin to displace. So, Yusuf, while here, what we did in this task, we found m at this specific point, right?
Yeah.
And we already given with x and y initially. You see?
Yeah.
And we don't know M and B to form an equation of a line. So we evaluate M first, and then substitute all unknown values here to all known values. Let me do it here real quick. So now, what are we doing? Y equals mx plus b. So Yusuf, tell me, what should I change to evaluate b?
Substitute a B.
Yeah, imagine if I'm giving this equation and I need to find b. How would you rearrange terms in this equation to find b?
Like make it B equals and then all
Yes,
the.
yeah, exactly.
Oh, like should I say it?
Pardon?
Should I like say it?
Yeah, same here.
Oh, so it's B equals
Yeah.
uh wait, negative B, right? Because moving it to the other side.
Or you can leave b on this side and move another term to the left.
Oh, okay, so then it's minus mx.
Minus mx.
Like B equals minus mx, right?
There's something else. There is one more thing to consider.
Oh, the y?
Yes.
Wait, so then it would be
You did minus mx, but you just
Yeah.
forget about y to the left hand side. And how do we write it down with y? So I'm not sure how you've been taught, but you're transferring terms over the equal sign, right?
yeah.
And you're changing the sign in front of a term.
That's how I do it. So wait, can I write?
Yes, sure.
So it would be B,
Okay.
no, minus B, I know.
Write as you feel it most comfortable for yourself.
Wait, 1 second. Can I do? I'm used to like doing it on paper. So 1 second.
Mm-hmm. Take your time. This is the last exercise that we're gonna cover in today's class, and you're free to go.
Sorry, what were we trying to solve again? I was working on 11A.
Pardon?
What are we trying to solve right now?
Right now we're trying to find b. The equation for b.
Oh, didn't we already do that?
Yusuf is trying to write it down now.
Sorry.
Yusuf, would you like some extra time?
Just 1 second.
Yeah, sure.
Oh, I got it. 1 second.
Yeah. Exactly.
Sorry
Yeah.
that I needed to do on paper.
Yeah, sure. No problem at all. I mean, the most important thing, you got it. Congratulations. And now you already know M, you know X, you know Y. Can you evaluate B for me? This is the value of M, and this is the value of X and Y.
Okay.
So evaluate B for me, okay?
Yeah. Wait, which one is M?
This 3.
Okay. And the X and Y is 6.
Point P that we are looking into has coordinate 3, 1.
Oh, okay. It's 0, right?
Well, you say 0?
Yeah.
Okay, let's evaluate. Minus 3 times 3, x equals 3, right?
Yeah.
Plus 1, negative 9 plus 1. Maybe I think that you took y equals 3, right?
Oh, yeah, that's what I did.
So yeah, keep in mind first position is x and second position is y.
Oh, yeah, I didn't pay attention to that. Sorry.
So value of b is negative 8. And now we know b and m. Yusuf, can you write me down the formula for the line? I gave you half of it. Just fill up the rest.
Sorry, which formula for the line?
Do you know the formula for the line?
Oh, yeah.
So now you know m of a
Yeah.
line, you know b of a line, and now write down the formula of this line, equation of this line.
Okay.
You see here, I already started y equals something x, something. And you already have a formula of a line here. On the top left corner of a screen, can you see it?
Yeah. So, y equals mx plus b.
Pardon?
Y equal mx plus b. That's the one at the top, right?
Yeah.
Yeah.
So what would be the equation of a line? We already evaluated all the necessary information.
Yeah.
We got m. What is m?
For like this or
M. M value. What is m?
3.
In other words, m is what feature is that?
Oh, it's the height. Wait, no. It's a slope, sorry.
Yeah, exactly. And b?
And b is
Y-intercept.
yeah, y-intercept, yeah.
So, and you know the formula?
Yeah.
For line. So write me the formula for this specific line that has m equals 3 and b equals negative 8.
Also just like
Mm-hmm.
Is that what you mean, or?
Yes, exactly. But remember, b is not equal to 8.
Oh, what was B?
It's right here.
Oh, -8.
Perfect. So the equation of a line, the tangent to the given curve at a point 3.1 is y equals 3 times x subtract 8. And if you draw this line and you draw this graph, you're gonna see that in fact they're gonna have only one connection point. It's 3, 1. Yusuf, sticking 3 into this formula, what would be the value of y?
Sticking 3. 1 second.
Three times 3 minus 8.
One.
Perfect. And you can see that it's exactly the same value that this function would take if we're sticking 3 in here. It's also going to take value of 1 because it's even given to us. Can you see it?
Yeah.
Perfect. Thank you for working, guys. Thank you. You deserved your rest. Well deserved. And looking forward to see you on Thursdays. And I would ask you, do you have the access to the Google Drive, right?
Yeah.
For next home assignment, you don't need to solve anything. Just please read the chapter 2 introduction. Okay.
So there's no like any extra homework to do?
Only the one I gave you at the first 2 classes. Finish
Oh,
that
okay.
one and head it in.
Okay.
And already you have 5% for classwork for this first chapter we covered.
Mhm.
I'm going to add so sorry that I didn't add you a proper schedule so far, but I'm going to structurize it into classes, and I'm gonna add due dates for quizzes and tests. Okay.
Yeah, I was going to
Almost.
ask you.
Yeah, sure.
Yeah. Well, when are we gonna have like a test?
We're going to have quizzes in between chapters,
Okay.
and we're gonna have one final test.
Okay.
And home assignments, you don't. I've been told that I can choose a deadline for you, whatever I feel like, but I'm not setting you any deadlines for assignment. So you can hand in assignments up to the end of this course.
Okay.
But I wouldn't recommend you do it that way, because if you don't do home assignments, it would be harder for us to move on in this course. Okay. So please don't do, when I give you a home assignment, no need to do everything out of it for the next class. Solve at least one example from the beginning, one from the end, okay?
Okay.
And feel free to contact me if you have any problems with home assignment.
Okay.
Perfect, guys. Have a good afternoon. Nice to see you.
Thank you.
Have a good one. Good luck.
You too.
Good luck.